In activity 1.9, we can take advantage of Desmos to complete a table of values, to simply evaluate a given equation, use a trial and error method to attempt to solve an equation, and also construct a graph of an equation to solve an equation graphically. So what we'll look at first is what we're asked to do in question 1 is for the equation y equals 2.5x, complete this table of values. So starting with a blank Desmos document, we can insert a table, and in place of y1, we'll type in the right-hand side of our given equation, so 2.5, and reference x1, the variable in that first column. So now we can simply plug in values, and Desmos will automatically complete those calculations for us. In question 2, now we're asked to use a table of values to estimate how many tickets must be sold to raise $200. So now we'll get into a little bit of guess and check. We could have students use some strategic guessing based off the values they've already completed, and then they can continue to plug in additional values until they get closer and closer to that result that we're looking for. In order to solve this equation graphically, which we'll be asked to do in question 3, part C, we can type in our equation, y equals 2.5x, and we'll specifically be asked to find the number of tickets that we would need to sell to raise at least $200. There are a couple of different ways to go about this. We can zoom out, to get a better view of our graph, and I'm going to go ahead and turn off these points that I've already plotted since I want to assume that I don't already know the answer here. So I have my graph constructed. If I click and hold on this line somewhere, what I get is something similar to the trace feature on a graphing calculator. So then what I can do is click and hold and slide this point, and it's going to give me the x and y coordinates as I move along. So what we would want to do is find for a y coordinate of 200, what is our corresponding x coordinate. This method usually works pretty well. Sometimes you may need to zoom in a little closer. The numbers that it reports back to you may kind of end up on one side or another of the value you're actually looking for, especially if you're looking for a specific decimal place. So another more precise method, an alternative version, would be to essentially solve this by finding the point of intersection between two lines, which is a concept you may not necessarily need to fully explain to students. But what you could tell them is, we're looking for the x coordinate that occurs whenever y is equal to 200. So if we type in y equals 200, we get this additional line graphed, which is representing all of our values where y is equal to 200. And then if we've clicked on either of these lines, we'll see that highlighted point, which is giving us that intersection. So it's just giving us a more precise method to find that specific point that we're after. If what we wanted to do was find the y value for a given x value, similarly we could say when x is equal to 20, what's our corresponding y value? So we'd be graphing all of our points where x is equal to 20, and we could find that point of intersection.